Shayla Harrowfield, National Renewables Manager for PAC Energy. We're a dad and daughter-owned South Australian business specialising in off-grid power for alternatives for diesel generators. We hire and sell our range to construction, mining, government and oil and gas. An important disclaimer up front, I'm not the technical or engineering part of PAC. My job is to understand what our products do and how they can add value to our customers. So I apologise for all the hydrogen and battery nerds in the audience. You won't get much technical brilliance from me in the Q&A. That said, there is already an abundance of complex information about renewables in the market. So I'm hoping my non-technical take on our real-world experience proves useful to some of you. So our core brand is simple. We focus on the hole, not the drill, to find the right solution for each customer. We spent most of our early product and business development trying to understand how construction companies could reach their carbon reduction targets without compromising their budgets. What we needed to know was where generators were being used today, where companies needed to be, and then how we could bridge that gap. So what we found was that construction companies rely on generators for 9 primary applications in construction. That 8 of these are light duty cycle applications, such as powering portable buildings and cranes, and that diesel generators are extremely inefficient at running these light duty cycle loads. Why are diesel generators so inefficient for most of the things we do in construction? Well, we have to size a generator to power the largest peak load on site, yet most of the time, 90% of the time, site load is a lot less. It means most of the time a generator is running well under capacity, producing unnecessary mechanical energy. It goes out the exhaust, oops, and I hit next, as wasted carbon and fuel costs. So take a typical site compound of 3 to 5 buildings powered by a 20 kVA generator. As you can see, the peak loads occur sort of smoko and lunch times of the day, and for the remainder of the day and overnight, site loads are dramatically less. That generator is capable of producing 336 kilowatt hours of energy in a day, while the site actually only needs 40 to 60 kilowatt hours. So put simply, that generator can produce the entire power demand of that site for the day in just 2 to 4 hours of runtime. So that's where we harness battery technology. To replace diesel generators up to 75 kVA, we use what we call a compact hybrid called the Purple Pod. Inside is a diesel generator coupled to a battery stack with rooftop solar. They are a fully automated system that run the diesel engine for 2 to 4 hours a day to charge the batteries, shutting off once complete, saving 20 to 22 hours of diesel use a day. Then we go above 75 kVA and we switch to our smart modular BESS systems called Purple Cubes. They follow the same principle except with a separate generator to allow some flexibility in battery to engine ratio, but also because moving around a 500 kVA all in one unit would be extremely difficult. Some results we've found in the field is that on average, we're seeing a 5 to 10% reduction in overall cost and a reduction of 65 to 90% in carbon emissions. Engine hours reduced from 8,750 to under 1,000 per year. Maintenance dropped from 34 services annually to just 2. And now one technician can manage over 120 Purple Pods instead of managing just 30 diesel generators. A WA mining company reported a 50% cost saving with hybrids over diesel, even with diesel priced at just 70 cents a litre. Other pluses include reduced noise, extended operating life, reduced NOx emissions, and for those on site, you can now store your half-finished iced coffee in the fridge overnight with guilt-free 24/7 power. Yes, so our EcoLight, this is a joint venture product with BOC and TCP from the UK. It represents our first Australian trials for a swap-and-go hydrogen light tower. With current hydrogen prices, the operating cost of the eco-light is about $1,000 a week compared to $550 a week for its diesel equivalent, diesel light tower. So from the foundation of the eco-light, we have designed Glowbug, which is due to land in Australia in July. It is a solar hydrogen hybrid light tower that it's been designed to replace be cost competitive against diesel without the carbon and without the noise, and also removing the reliability challenges faced by pure light solar towers. While the eco light runs at about $1,000 a week, the Glowbug will bring that down to about $530. So we look forward to that coming. Our knowledge is constantly evolving, but we have identified 3 key areas of focus for construction companies when it comes to reducing carbon in off-grid power. Firstly, power. That is what I've covered already. If you replace a diesel generator with the correctly sized hybrid, you'll reduce your costs by 5 to 10% and your carbon by 65 to 90%. Secondly, behaviour. This has been a really interesting learning for us. With our Madokan carbon software, we've been able to identify that site behaviours like leaving doors open and air cons overnight are responsible for up to 40% of wasted energy costs. And then thirdly, appliances. This is our next development. We are in deep trials and discussions with pump and portable building manufacturers to further drive carbon and cost reductions throughout the entire supply chain. Ultimately, though, if you can implement energy efficient appliances and equipment throughout your construction sites and compounds, it will significantly affect your energy consumption. Finally, to say this journey has been fun has been an understatement. Being able to collaborate with people like yourselves and work towards a shared goal has been incredibly rewarding, both professionally and personally. I want to thank you for the opportunity to present and look forward to answering some easy questions in the Q&A. But please go easy and brief on these. I've just about burned through 4 tons of carbon off here already. So thank you.